All right, this is a video for the worksheet 2-1 for experimenting with discovering compound and simple interest. So in this one, we are first trying to find the end. So we have to say, how many times is it going to compound when we use this word? So the first one says compound daily. Well, if I compounded daily in 1 year, I would compound 365 times. Now, if you put 360, remember we talked about banking days versus regular days? That would be all right as well. I would take that answer. The second one says compound monthly. If I compounded monthly, I would compound 12 times in a year because there are 12 months in a year. All right? And if I compounded weekly, there are 52 weeks in a year. So in 1 year, I would do 52 times. And these are just my ends so that I know in my formula what the n part is. If I compound semi-annually, remember the word semi means 2, you would compound twice in 1 year. Bi-weekly, if there are 52 weeks in a year and I compound every 2 of those weeks, it would be 26 times in a year. And semi-monthly, if I compounded twice in a month and there are 12 months in a year, it would be 24. All right, so that's how you find the n. You have to look at that compounding amount and figure out how many times it would happen in a year. So I'm going to pause and put up the answers to the rest of the questions. There are 3, so that you can correct them before you go on and watch me working them out. So just hold on 1 second. All right, so go ahead and check your answers. As you see, I put 360 for daily. If you use 365, your number is going to be slightly off. And also remember, where you round, you shouldn't round your answer until the very end when you do these problems. But because we're all using different types of calculators, those calculators have particular string errors. That means only so many characters you can type into them before they stop working. It's just not possible for everybody in the class to be able to round at the same, to be able to leave their rounding until the end. So you may be a little bit of change off from me. Don't worry about that. That has to do with our particular calculators and whatnot. Okay, so let's go ahead, and I hope you paused, you checked this. I'm going to get started on explaining how to do these. Okay, so at age 27, Jill deposited $4,000 into an IRA where it earns 9.8% interest compounded monthly. What will it be worth when she is 35? So first I got to find out my time, right? Because if I lay out all of my different variables, I know that I deposited 4,000, so that's my P. My rate is 9.8% or 0.098. My time I don't know, but I do know that I'm compounded monthly, so the n is 12. I don't know my time because I need to take 35 and subtract 27, and when I do that, I'm going to get 8. So my time is 8 years. All right, now I can put this into my formula. All right, I'm just putting in all of my variables that were given to me in this problem. Okay, so if you have a super duper calculator, the TI-30s pluses like I have, they can do this entire problem in there, okay? You would type it exactly how it's seen with a little caret and then put your exponent in these parentheses, okay? So you wouldn't have to do any different than the way I wrote it. Just put it exactly into your calculator like this. But if we have string errors because we have different types of calculators, especially phone calculators, they cannot carry this many characters, then you're going to want to do the parenthesis first, this part. Let me change to a different color. You'd want to do this part first in the parenthesis, then apply the exponent, then in your very last step, you would want to multiply it to this. Okay? So you would want to do all those steps, okay? So let's go ahead and do the steps, and my answer is going to come out slightly different if I have to do it in steps than, you know, just put the whole thing in my calculator, because then my calculator rounds it at the very end. But if I have to do it in steps, this is how it would go, and I'm going to get a slightly different answer. So I'm going to take it out to the 5th digit and round up. I'm going to go ahead and figure out what 12 times 8 is. All right, next I got to apply order of operations. Next is the parenthesis. So I'm going to figure out, parenthesis. I already did the parenthesis. Next is the exponent. So I'm going to figure out what that is. All right, and I'm going to have to bring my problem over here. And I'm going to bring it out to the 5th digit and round up. Now I can take that number, okay, and I'm going to multiply it by the other thing. By the 4,000. And that is a completely different answer than the one I got. So give me 1 second. I think I know what I did. Looking at the numbers, I think I accidentally put in 400, but just give me 1 second to figure this out. To put my numbers back in and see if that is what I did. Sometimes I make mistakes. That is why we have calculators. Yes, that is what I did. So my answer should have been in my answer key, but I forgot a 0. Let me just erase it and write it again. And as you can see, they're slightly off. This one gave me just slightly a little bit more money because of that rounding, okay? So if you're rounding out to the 5th decimal versus waiting till the end to round because your calculator can take the whole equation at once, you're going to get 2 different numbers. This is how the bank does it, by the way. They put the whole thing in at once, so you're getting the smaller amount. But when you round, it changes things, okay? So we have to be very particular about our rounding. All right, I'm gonna make this slightly bigger. I'm having trouble seeing it, but I have really bad eyes. All right, let's look at the second one. If you have $3,500 after 10 years on an investment that pays 5.3% compounded daily, what was the principal amount you started with? So what was the P? So let's go ahead and write down what we know of our formula. We know the amount we ended with, 3,500. We do not know the principal because that's what it's asking for. We know that it's at 5.3% interest, which is 0.053. We know that the investment's for 10 years, and we know it's compounded daily, and I'm going to use 360, but if you use 365, it's okay because I didn't clarify. And you're going to get a slightly higher answer than I am. So now I got to put everything that I know into my formula. And this is just simple opposite operation for solving for an unknown variable, just like we did with simple interest. You're doing the same thing here. times 10 years is going to give me an exponent of 3,600. All right, so this one I have to do in parts, and I have to, you know, round. So I'm going to be rounding out to my 5th digit. Okay, so the first thing I have to do, order of operations, what is in the parenthesis. So if I put all of this in my calculator, I'm going to get 1, 2, 3, 4, and I'm going to round up. So now the next thing after parentheses and PEMDAS is exponents. So I'm going to put that 1.69887 into my calculator to the 3,600 power. Remember, oh, I got an overflow error. Hold on. Remember, I got 3,600 because of that multiplying it by 10. I keep getting an overflow error. Because no, my decimal's in there. Overflow error. It must be too many digits for my calculator. Isn't that great? I'm going to do it this way then. I know it worked because I worked it out before. So it's got to work. It's got to work. But I think I did it all in one fell swoop, but that's not how I taught you guys to do it because that's difficult to understand. Okay. So yes, this is, okay, that's what I did wrong. You do what's inside here. I skipped a step. I forgot I did it all in that step. Okay, so you do what's inside here. 1 plus 0.053 divided by 360. And you actually should have gotten this. One, two, three, 4, 5. Then you put in your exponent and you get this. Okay, so this is what I have now. To get p by itself, I'm going to have to divide both sides by the 1.69887. And when I do that, I get that p equals, because this is going to cancel out, leaving me just with p, $2,060, and if I round up, 20 cents. All right. Let's do the last one. A 175 loan compounded monthly at 3.2% for 19 years. How much interest would it earn? All right, so I got to write down everything that I know. And then I got to place it into my equation. All right, and let's go ahead and do this in steps. For those of you who have string error, we're going to get slightly different than the answer I got, and I'll show you as we go along. So I'm going to do order of operations, do what's in the parenthesis first, and I'm going to round it to the 5th decimal place. 2, 3, 4, and 5. All right, now I'm going to take that number and I'm going to raise it. So let me clear 1.00267, and I'm going to raise it to 12 times 19th power. Sorry for the noise in the background. Which is going to give me 1 point, and I'm going to take it out to the 5th digit. 3, 4, 1, 2, 3, 4, 5. Now the last step is to take that and multiply it by the 175,000. All right, and this is what I get. And when I did it, just putting it all in the calculator, I got 321,171.98. So remember, rounding is actually going to make a bigger difference than you think. So if you did it in steps, this is what you would have got. If you have a calculator that can do it exact for you, then you would have gotten 321,171.98. So they're slightly off. Actually, they're a couple $100 off. And this is what the bank would actually use. All right. But that's not what the question asked. The question asked the interest. Okay. So if this is what my principal is, and this is what my amount is, okay, remember the amount is always made up of principal plus all the interest we earn or we pay on a loan. So I know what my total amount is, and I'm going to use this one. You're going to see it's going to be a slightly different answer, and that's okay. We have string errors on our calculators. I'm not expecting good calculators here. And my principal amount was this. Then to get I by itself, I have to do the opposite operation, which means subtracting this from both sides. All right, so let me do that. And I get 146,415. Again, it's actually a couple $100 difference. So if you've been rounding to the 5th place and doing it using order of operations, you're going to get this answer. If you're using a fancy calculator that doesn't round to the very, very end, you should have gotten this answer. Either way around it, what you needed to do was subtract your principal from your total amount that you're paying on the loan to figure out how much interest. Look, this person is almost paying double in interest. Now let's think about that. 3.2% is a very good home loan. And this is for 19 years and it's compounded monthly. That means over the course of this loan, we are going to have to collect interest on it 228 times. Look at that. Now, home loans are calculated slightly different. They're actually use compound interest and an amortization table, which means they only compound off of what is left on the principal, and the principal is constantly changing. We don't make one of those in this class. They're kind of complicated. When I was a college instructor, we used to make them all the time. But this is kind of, whenever you buy something, you got to be thinking that the longer, I mean, for an investment, this is really good, right? But for a loan, no. No, it's not good. The longer the time, the more you're going to pay back, okay? The more you're going to pay back in interest, except for that amortizations work a little bit different. But when it's straight compounded, then we are going to pay a ton back, okay? All right, so keep working on these. Let me know if you have any problems, and I will see you guys in class.